Lesson 5.4 is all about solving inequalities. So last lesson you learned about graphing inequalities and writing them. Now we're going to talk about solving them. So pause the video, work on the warm-up, and then we'll go through it. Write an inequality for the sentence and graph it. The weight of a bowling ball for an adult is greater than 15 pounds and at most 16 pounds. So we know X is our bowling ball. X is greater than 15 pounds. And we know it's at most 16 pounds. So X is either going to be less than or equal to 16 pounds. It's going to be no more than 16. So when we smush those together, we get 15 is less than X, and X is less than or equal to 16. Number 2, write an inequality for the graph. We have X is greater than, because it's an open circle, we don't put the line underneath, greater than negative 2. So, for example, if I pick a point, 0, 0 is greater than negative 2. 5, 5 is greater than negative 2. So, X is greater than negative 2. Solving inequalities. You produce equivalent inequalities, inequalities that look different but have the same solutions. So the steps are similar to solving equations. Work must be shown on both sides. So we're going to keep drawing that line down the equal sign. Just like a balance beam, I want to see it work on both sides. Key concept. Write this down after I explain. Addition and subtraction properties. So when you add or subtract the same number from each side of an inequality, the inequality remains true. So all this is saying is that when you do the same thing to both sides of the inequality, it still remains true. Just like how we use the balance beam for solving equations, it works with inequalities as well. So I would write down this in words, and I would write down these examples. Solve and graph. N plus 7 is greater than 3. So we're going to solve just like we would as if it were an equal sign. We're going to get n by itself. Well, this is a positive n, so we have to subtract n from both sides or add negative n. I'm left with n is greater than 3 plus negative 7 is going to leave us with negative 4. So thinking back to our graphing rules, I'm going to plot negative 4, and I'm going to plot two numbers to both sides of negative 4. I'm going to plot negative 3 and negative 2, negative 5 and negative 6. Then I am going to graph. N is greater than negative 4. So we know it's going to be an open circle, and it's greater than negative 4, which means my arrow is going to point to the right. So if I plugged in a point to try it, negative 2. Negative 2 is greater than negative 4. That works, so I know my graph is correct. Second problem, 10 is greater than or equal to y plus 4. Okay, I'm going to treat this just like it were an equal sign. Draw the line down the middle. I'm going to get y by itself. I have plus 4. To do the opposite of plus, I'm going to subtract 4 from both sides. I'm left with y is less than or equal to 6. Now I'm going to plot 6. I'm going to plot two numbers to both sides. I'm going to count by 2's this time, so we'll do 8 and 10, 4 and 2. We know our point is going to be at 6, and it's going to be colored in because it is greater than or equal to. So 6 is greater than or equal to y. I always like to write this in reverse. I like to have my y first. So y is less than or equal to 6. So if y is less than or equal to 6, that means our arrow is going to point to the left. And we can try a point. So if we plug in 2, is 2 less than or equal to 6? Yep. So we know our arrow is pointing the correct way. All right, h minus 1.5 is less than 5. Well, I'm going to draw my line down just like an equal sign, trying to get h by itself. So we have minus 1.5. I'm going to add 1.5 to both sides. I'm left with h is less than 6.5. I'm going to write that in decimal form, so I'm going to write that as 6.5. H is less than 6.5. I then need to graph it, so I'm going to graph 6.5. I need 2 dashes to the right and 2 dashes to the left, so I'll do 7.5, 8.5, 5.5, and 4.5. I know my circle is going to be above 6.5, and it's going to be an open circle because it's just less than. And h is less than 6.5. So if I plugged in 5.5, well, that works because 5.5 is less than 6.5. So my arrow is going to point to the left. Multiplication and division. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So again, what this is saying is that if you multiply or divide by the same number on either side, as long as it's positive, it doesn't change the inequality. So I want you to write down the words and the examples. All right, let's practice. Juanita is going bowling and has $25 to spend. If each game costs $4, find the maximum number of games she can bowl. Write your answer in a sentence. Okay, so she has $25 to spend. So 25 is going to be less than or equal to whatever the cost of each game is, because she only has $25 to spend. Oh, excuse me. We're going to actually change that. 25 is greater than or equal to, because anything she spends has to be less than or equal to 25. So each game is $4. Because it says each, we're going to multiply 4 by x. We're trying to find the maximum amount of games she can bowl. So we're going to solve this equation. Right now it's 4 times x. The inverse operation is division. I'm going to divide both sides by 4. And I'm left with 25 over 4 is greater than or equal to x. I'm going to flip this around and write x is less than or equal to 25 over 4. And I'm going to write this as a mixed number. So x is less than or equal to 4 goes into 25 6 times with 1/4 left over. So we know she has to play less than 6 1/4 games. We're trying to find the maximum number of games she can bowl. Well, she can't bowl a fourth of a game. So the max games she can bowl is 6. Negative coefficients. When you multiply or divide each side of an inequality by the same negative number, the inequality symbol must be reversed for the inequality to remain true. So if you have -4 is less than x and you multiply each side by a -3, it's going to flip the sign. So when you multiply or divide by a negative number, it's flipping that inequality sign. So I want you to pause it and write down in words and examples. Solve and graph. -9x is less than -27. So we're going to solve this to get x by itself. Right now it's -9 times x, so we're going to divide each side by -9. Because we're dividing by a negative number, we are flipping the sign. So we're left with x is greater than 3. We are then going to graph it. So 3, 4, 5, 2, and 1. It's going to be an open circle, and x is greater than 3. So if I plug in the number 5, is 5 greater than 3? Yep, so our arrow points to the right. We have x divided by negative 5 is greater than or equal to 7. Well, in order to get rid of that division, we're going to multiply both sides by negative 5. I'm left with x. We're flipping that symbol. Is less than or equal to, because we're multiplying by a negative, so we flip the sign. 7 times negative 5 is negative 35. Then I want you to graph that on your own. I want you to try both of these problems before starting the homework. So pause the video, solve the problems, make sure you solve and graph, and then you can start the homework. All right, the homework is here. Pause the video to write it down and then get started.